In this video, we're going to learn about Doppler's effect. This is the basic equation where Fa is apparent frequency equals to V is the actual speed of sound in the air plus minus speed of the object over speed of the sound in the air plus minus speed of the sound of the source times the actual frequency. The definition of all the symbols are here. Okay, so we go here. We have 4 situations altogether. Let's go to the first one. Observer and source. Here we have the source moving towards the observer. So I'm going to put here the label, the dot for the source to indicate that this one, the source, is moving towards the observer. And for that, it shows that I have negative. So for the apparent frequency, Fa equals to, the one that is not moving is the observer. So basically, it's supposed to be plus or minus VO. But because VO is 0, I'm just gonna erase this one. And we don't have to write down anything for the VO. We just leave the V like that. So V, this one we got negative, so I'm going to put here negative speed of the source darabkan dengan the actual frequency. So this is our equation for this situation. Next we go to the when the source is moving away. Again, the V observer equals to 0. So I'm not going to do anything because based on here, if the VO is 0, I'm just going to leave the V at the top alone. So apparent frequency equals to V over V. So I don't know whether it is plus or minus. Let's see, I'm going to do the dot on the S, which is the source. Because from here, I can see that it is moving away from the observer. So I can see that I got plus V for the source darabkan dengan actual frequency. Next, for the third situation, here we have, okay, this time the V of the source is equals to 0. So I'm not going to do anything. So the dot goes to the observer. Okay, so I can see that the observer is moving towards the source of the sound. And for that, it is Fa equals to V. So we got plus V observer over V. I leave out the Vs because Vs is 0. So it's going to be like that times the actual frequency. That's it. That's our equation. And for the last situation, the dot again goes to the observer because observer is the one that is moving. So the arrow away from the source. So means that I got negative. Fa equals to V minus V observer over V times actual frequency of the source. So this is just a graph of apparent frequency versus distance travel. As the source approaching, we can see that this is apparent frequency. As it gets closer to the observer, we can see that we can hear it in its actual frequency. And then as it moves away, the frequency starts to get lower. So here we have the description. Approaching, the apparent frequency is bigger than the real frequency. So you're going to hear very high pitch. As it moving away, you can see that the apparent frequency is much lower and you will hear lower pitch sound.